When we look up at the night sky, it's easy to be awed by the sheer number of stars and the immensity of space. But within this vast expanse lies our own neighborhood, the solar system, a complex, beautiful, and dynamic system that has fascinated humanity for centuries. But how exactly does it work? Let's break it down and understand it in simpler terms, starting with the central figure of this cosmic ensemble, the Sun. At the very heart of the solar system lies the Sun, a gigantic glowing ball of plasma that serves as both its anchor and energy source. The Sun accounts for an astounding 99.8% of the total mass of the entire solar system. This enormous mass gives it a powerful gravitational pull, which acts like a giant cosmic magnet holding everything in orbit around it. Without the Sun, the planets, moons, asteroids and comets would drift off into the cold darkness of space. The Sun's energy comes from nuclear fusion, a process where hydrogen atoms combine to form helium, releasing enormous amounts of energy in the form of light and heat. This is the same energy that lights up our days, supports plant life through photosynthesis, and drives weather and climate patterns on Earth. Imagine how lifeless and frigid our planet would be without the Sun's constant warmth. Now, let's move beyond the Sun and talk about the planets that orbit it. There are 8 major planets, each distinct in its characteristics and distance from the Sun. Closest to the Sun is Mercury, a small rocky planet that experiences blistering temperatures during the day and freezing conditions at night. Venus, next in line, is known as Earth's sister planet because of its similar size, but its thick, toxic atmosphere traps heat, making it the hottest planet in the solar system. Then we come to Earth, our home. Earth's position in the solar system is ideal. It's in what scientists call the Goldilocks Zone, where temperatures are just right for liquid water to exist. This is essential for life as we know it. Beyond Earth lies Mars, the red planet, which has been the subject of countless exploration missions due to its potential to have once harbored water and possibly life. As we move farther out, we encounter the gas giants Jupiter and Saturn. Jupiter is the largest planet in the solar system, a massive ball of swirling gas that is famous for its great red spot, a storm that has raged for centuries and is larger than Earth itself. Saturn, with its stunning rings made of ice and rock, is one of the most visually striking objects in our solar system. The outermost planets, Uranus and Neptune, are known as ice giants. Unlike Jupiter and Saturn, they contain heavier elements like water, methane, and ammonia. These planets have unique characteristics. For example, Uranus rotates on its side, making its rotation unlike any other planet. Orbiting some of these planets are their moons. Earth has one moon, which plays a crucial role in controlling tides and stabilizing the planet's rotation. Jupiter, on the other hand, boasts over 79 known moons, including Ganymede, the largest moon in the solar system. Some moons, such as Saturn's Enceladus and Jupiter's Europa, are intriguing because they have icy surfaces that may conceal oceans beneath, sparking curiosity about their potential for life. Between the orbits of Mars and Jupiter lies the Asteroid Belt, a region filled with rocky debris left over from the early days of the solar system's formation. Occasionally, pieces from this belt break loose and travel toward Earth, becoming meteors when they enter our atmosphere. If they make it to the ground, they're known as meteorites. Comets are another fascinating component of our solar system. These icy bodies originate from regions like the Kuiper Belt and Oort cloud, far beyond Neptune. When a comet approaches the Sun, the heat causes it to develop a glowing tail of gas and dust, creating one of the most spectacular sights in the night sky. The orbits of all these celestial objects follow the laws of gravity. This was first understood by Johannes Kepler, who discovered that planets move in elliptical, oval-shaped orbits with the Sun at one focus of the ellipse. Kepler's laws explain why a planet moves faster when it is closer to the Sun and slower when it is farther away. These principles, combined with the gravitational interactions between bodies, create the balance that keeps the solar system functioning like a well-tuned machine. One of the reasons everything stays in place is because of the Sun's gravitational force, which extends far beyond the planets, creating the heliosphere. This bubble-like region helps shield the solar system from cosmic radiation and marks the boundary between our solar neighborhood and interstellar space. Imagine a symphony where each musician has a role, some playing loudly like Jupiter, while others, like the tiny asteroids, contribute subtle notes. This cosmic arrangement operates harmoniously due to the Sun's gravitational pull, the inertia of moving bodies, and the complex web of interactions among them. Whether it's the gentle pull of the Moon causing tides on Earth, or the fierce winds of Neptune that surpass the speed of sound, every element contributes to the grandeur of the solar system. In conclusion, the solar system is not just a random assortment of rocks and gases drifting through space. It is a finely balanced system held together by the powerful influence of the Sun, the dance of gravity, and the intricate orbits of planets, moons, and smaller objects. This grand dance has persisted for billions of years and will continue to fascinate and inspire us as we strive to understand more about the universe we call home.